Okay, Justin, thank you very much. That was really interesting. Um, I've asked you all to put questions in the chat if you have any, but unless I'm doing something wrong here, I don't see any questions in the chat. Um, Mary, I think there was one question submitted online ahead of time. Is that
Y-
right?
Yes, I had the question, will the recordings of these meetings be available for access at the end of the series? And I can actually answer that question. The recordings will be available from the presenters who give consent for the recordings to be posted. And the PDF presentation will also be available on the meeting website. It usually takes a couple weeks to a month for them to be posted. It shouldn't take too long though, because there's not a whole lot of presentations. Um, and I will send out an email as soon as they're available to anybody who is registered for the meeting.
I'll also reiterate that if you're eager to get going, if you just send us an email, I'd be happy to provide my own slides or provide any answers to the questions for specific facilities or what have you. We're here to support your user needs, and we're also, and I didn't mention this, and I should have. One of the things that makes the NFAR facility proposal notable is it's within the ARES I guess capabilities and mission that we have, which is also in training. And so we expect to have people who have questions contact us so we can help direct them. It's not as though we expect you to know everything. So feel free to contact Lindsay or Liz or Francis or myself or other people here, and we'll set you straight as best we can.
Okay, we have one question in the chat. Are the laboratories at JSC busy at particular times of the year?
Yeah, that's a super helpful and important question, and the answer is absolutely. We are busy all year long. I mean, we have, and this is part of the point I was trying to make at the beginning is that we are a very active group of scientists, and it's a win-win, right? We're expanding our capabilities and bringing in new collaborations. And what have you. And so having this funding is helpful because it provides that sort of that warm cup of coffee in the morning to keep us stable and going forward. Your question really is about times of the year. These are the typical times for an academic scientist as well in terms of research. Leading up to LPSC or Goldschmidt or METSOC, and these are times where the facilities are highly subscribed. And in general, part of our promise to our selectees is that we'll get their proposed work done, but we also want, and tell them that they have to recognize that we are fitting this in to a full schedule. I mean, almost all of our highly sought after facilities are scheduled out. So it's not like you could walk in to the building and expect to get onto one of these. But we are committed to making sure people get it done. So if you have a question about a specific facility, I would recommend in terms of timing and usage, I would recommend that you reach out to the laboratory manager or to one of those 4 people that I mentioned, and we can help guide you. But if you're looking to get data for LPSC and you contact us even in October, it'll be difficult. Certainly don't contact us in December and expect to get results for January 7th.
Justin, I actually have a question myself for you. Somewhere early in your presentation, you mentioned laser fluorination MS for oxygen isotopes. Is that part of your lab at CICG, or is that
No,
no,
it's not. This is run by Paul Niles and Justin Hales. There is maybe a little confusion because there's a couple Justins here. And it's a different facility. It's been around for a long while, actually, the sort of desire or the capability to make stable isotope measurements. Most in the past, it was primarily focused on solutions and some gases, but we recently, when I say recently, I mean last 4 or 5 years, added the laser fluorination line, which allows us to look at silicates and oxides and sulfides, other solid rocks. And so, and we have not done a ton of measurements for the external community yet. We have had one successful NFAR proposal submitted, and I'm not exactly sure where we are in terms of those measurements, but Justin Hales has demonstrated the ability for it to work and has run standards, and it's I would say state of the art. I mean, it's really doing well. We can make three oxygen isotope measurements. So that is, both the stable, but also the triple oxygen isotope measurements uh, of bulk materials, but also small materials. It's not a in situ yet, but it is a laser that's hitting a sample. Typically, you have a small pile. You have a couple crystals or something like this that you're hitting with the laser and fluorinating it, and then you're extracting out the oxygen through the cryo line. But it allows us to measure these solids and to a very high precision and accuracy. I don't want to misquote their current capability, but it's as good as anybody is doing in the world. I would say it's certainly better than 10 ppm precision. If Justin was here, he would argue that it's more like 5, somewhere in that category of precision. So oftentimes you see per mil level effects in astromaterials, and where I was quoting per 10 parts per million, not parts per thousand, that we can do. And so 10 parts per million, when many of the variabilities or variations that we see in astromaterials is parts per thousand, or if in some cases you have a pre-solar grain, it's even weight percent. Of course, then I would recommend that you use the nanosims or some other facility, because you don't need that kind of precision, and maybe you need spatial resolution that those in situ techniques do.
Phew, that was good.
Okay, thanks.
Either that or Zach did something upstairs.
Somebody, I don't know who's talking, but we do have one question in the chat now. When we take samples from their natural environment, how do you confirm we get the same chemical composition on the outer surface of the sample?
I think the question has to do with sample handling. And it's a really good question. And it really depends on what type of analysis you're aiming to do and what kind of questions you're asking. Aaron would answer this question differently than I would. His I would say his bread and butter when he was a bench top scientist or bench scientist was organic materials and prebiotic studies. And I don't want to speak for him, but he looks at my lab and thinks, oh my goodness, there's plastic everywhere. Those gloves, they're terrible. It's confusing everything that I'm trying to do. Whereas I'm very concerned in the inorganic labs with particulate and inorganic contamination. So it really depends on what the scientific question is. But typically, if it were a geologic process or geologic sample, you would get a big chunk and you go after the interior to try to get away from the alteration or the weathering that you might have at the edges. Obviously, with astromaterials, you get what you get often, and you have to kind of characterize the entirety, if you will, and try to understand, what, looking through the secondary processes or the handling processes, what the primary or the pristine formation process was. Sometimes it's pretty straightforward. If you have a meteorite and it has a fusion crust, you can identify, and it's broken up. So you have a largely exposed fresh surface in the inside, and then you have the fusion crust. If you're interested in the fusion crust process, you would obviously look at the fusion crust. But if you're interested in the, what parent body that sample came from, like you, Serena, often do, you would, you stay away from the fusion crust and go after the interior. I don't know if that answered the question's question, but I could keep going for another hour about that.
Okay. Not seeing any new questions show up. Mary, could you go on to the next slide, please? Well, okay, there's something I wanted to say before this. I just wanted to thank both today's speakers again and point out that we have one more session coming up in this series. That will be next Wednesday afternoon at the same time. And our speaker is going to be Katie Robinson of NASA headquarters, and she'll be talking about how to write proposals and try to get funding from NASA to do all this kind of good work. The last the last slide, if you could put it back up there, Mary. I just want to point out, do a little advertising for LPI's next event coming up. We have a workshop. It will be a virtual workshop that's called Itakawa and the Dawn of Asteroidal Sample Return, talking about obviously the Hayabusa mission and the beginning of asteroidal sample return and the general topic of asteroid meteorite connections, and that'll be in late January. And I guess that's the end of our afternoon session. Thanks to everybody who joined us, and thanks to the speakers again.